Can you guys hear me okay?
Yes.
Loud and clear.
Thanks.
Who is piping in this suspenseful music?
Jeff, can you hear me? Hello?
Yes, I can hear you. I was
Okay, good.
on mute.
So let's start then. We are on time. So welcome to IETF 110 Thrift Working Group meeting. Chairs Jeff Tensura. We've got busy agenda for today. Tony is going to update us on Thrift-based specification updates, on Yank update, applicability draft update. Jordan is going to present Rift KV registry for the same time. There's great progress in segment routing and new work on auto VPN by Tony again. Working group status. We've sent 12 revision to ISG reasonably long time. There's a lot of work going on to address Alvarez comments. Hopefully we are keeping our ID happy. There are also weekly meetings to work on the comments. Applicability estimate draft has been in working group last fall for quite some time, still working on comments. Young, there's ongoing work, and SR work is progressing, new co-authors, and you'll see presentation today by Jeffrey. Not well, sorry, should have been the first slide. You're contributing to IETF and subject to IETF policies. If you haven't read Not Well, please do so. And we are ready for our first presentation. Tony?
Here. Sorry, I was on a yak, which does not stand for yet another compiler. It stands for yet another coffee. All right. So status update. Next one, please. So we'll talk day one book again and what's going on with Alvaro's review. Next one, please. Okay, so day one book, shameless plug again. It's for free. You can download it. It's a fat little thing that talks about Juniper implementation open source and deals with a lot of, the magic of the real implementations coming up and what the stuff looks like and further considerations when you build the fabric and so on and so on. So use it or lose it. Actually, you won't lose it. It's out there for free. Okay, next one, please. Right, so Alvaro is giving us a very nice review. He's slogging through the whole thing. Thanks so much. Most appreciated. He's learning, crash learning Thrift on the go. And we started weekly meetings to basically work through the comments and polish the document until we hopefully get him happy and move to the next step. So first big thing is that the document will go SVG, so that seems to work. So we are in a sense a little bit of a guinea pig because we're probably one of the first. But given how complex a lot of the figures are in the Rift spec, it makes sense. So Jordan volunteered to add a lot of these complex figures in SVG. And we already have FSN, SVG pictures, and so on. Jeff, can you kill the mic? You have sideways noise. And the bigger things that came out from the first meeting that we had there and some discussion was that we'll need to refactor the intro section. This really suffered from a lot of previous comments where we removed things like requirement section and so on. So we refactored that stuff into an intro. And it will need a reader's guide to understand for reader, depending on his interest, what kind of fabric he's building and how much he wants to implement of Rift, which parts need to be read and how they build up on each other. Some mild moving of sections will be necessary and lots of forward referencing to models. So on Alvaro's review, it became clear that we basically have this model as appendix at the end, and we kind of assume that somebody knows what the model is, and we don't forward reference enough when we describe the protocol and how it works. And then, of course, a lot of needs. And I think that's it. So that's where we stand.
Any questions?
All right, smooth sailing then.
Yep. Now we are moving to the applicability draft update.
Jeff, could you do full screen in presentation?
Yeah. Does it look good?
I don't see much difference.
I'm in full mode and it shows that I'm sharing the screen.
Okay. All right. Let's just proceed. Yeah.
Okay.
Here.
Can you hear me?
Yes.
Okay, sorry for the unstable connection. Hello, chairs and colleagues. I have a very short introduction of the latest status of Rift applicability draft version 04 on behalf of all the co-authors. Okay, next page.
Screen sharing fell down. Jeffrey, I think you need to screen share. Jeff may have stumbled over some cables.
Hold on one second.
Get jingles off your keyboard, please.
Jeff, you need to full screen.
Jeff, can you hear me? Anyone? Can anyone hear me?
Yeah, your voice is good.
Hello?
Have we lost?
I'm really sorry about the connection. I would be very quickly. So next page, please.
Did we lose Jeff?
Hello? Oh,
Yeah, well, I can hear you, but we seem to have lost Jeff.
okay, let's wait.
Jeffrey, why don't you share?
I'm here and sharing, right?
You are sharing, but the slides are not moving.
You are sharing, but badly.
Did it move now?
Yes, next page, please.
Okay.
It's not moving.
Let me try again. Sorry. Not sure what's going on with it. How about now?
Okay, yes.
Good.
Okay, the updates since IETF 109, the chairs announced a working group last call for the draft on December 10th, 2020. Comments received from Linda, Tommy, Mike, Samita, Watson are all addressed and reflected to version 04. From the comparison of version 03 and version 04, you may find mass editorial optimizations, and 2 chapters were added. Chapter 4.15, IoT applicability, and Chapter 5, security considerations. All these updates are based on the comments from the reviewers. Next slide, please. Yes, so I would like to hear guidance from chairs of the next step of the working group last call. And comments are always welcome. That's all for my presentation. Thank you.
Thank you, Sandy. So with regards to addressing comments from reviews, in general, people who provided comments don't track, they don't participate necessarily in routing area. So if you could reach out to all the people who provide their comment and ask their view on your updates, whether you address their comments, whether they're happy, that would be the right thing to do. Just reach out to everyone who provided their comments and ask for their guidance on the updated draft.
Do you mean that I need to get the response from those commenters, right?
Yeah, you want to know that your comments have addressed their questions, Because practically
Okay.
it's stateless from their perspective. They're not tracking what you're doing unless you tell them.
Okay, I see.
So next step for you would be reach out and ask for final comments, whether they're happy with how you address them. So usually there's some iterations. It's an iterative process to update document. And obviously we would like to finalize last call as soon as possible. So please do so, and we would love to finalize it within a couple of weeks. And thank you. Is it clear? Can you still hear me? I assume you can, right?
I can hear you, Jeff.
So, yeah, we are moving to the next presentation. Thanks, Sandy. And it's you again. Sandy, is there?
Yeah.
Okay.
Can you
so
hear
now
me?
we are talking. Yeah.
Okay. Hello everyone. I'm Sandy Zhang from ZTE. This presentation is for the update of Rift Young. We have co-author Bruno, Yuehua, Shaowen, and Xufeng. Next, please. The 02 update of this draft includes we added Bruno as co-author of this draft. And thanks Bruno very much for his work. And the Young model is updated according to the implementation experience and the Young rules. Xufeng gives many suggestions about the Young model rules. Thanks Xufeng very much too. Next, please. And this is the overview of the model. The model is defined according to Rift protocol draft. The model includes protocol configuration, state information, and notification. And some features are added to enhance the protocol. Except for the co-author, we also thank to Tony and Benchong for their detailed review and valuable comments. And next, please. The overview of the Rift model is, as we can see, multiple Rift instances are supported, and there's writable data in node and the interface configuration. The state information includes node, interface, neighbor, and database. Next, please. And this is the interface configuration and state. The configurable data is used for message exchange that includes some parameters and capabilities. Next, please. This is the neighbor state. The information received by the neighbor includes the neighbor node information, interface information, and some other information, such as if the BFD session is up between the local node and the neighbor. Next, please. And this is the database state. The database information includes the base type information, such as the direction type, originator, and something else, and the detailed information of the node type, prefix type, and the key value store. Next, please. The information part includes the type and the neighbor error information. Next, please. It's great to have more review on this draft. And if working group agrees, we'd like to request a working group last call for this draft. That's all. Thanks. Any comments?
A few comments from my side. Thank you, Sandy. Tony, do you feel there's a need to wait for version 13 to accommodate changes?
No, I don't think Alvaro's comments will be changing the model or have any, fundamental mechanism or anything like that. No, I don't think so. I still have to review this last version of the Yang carefully, though.
Okay, so next step here is going to be sending request for review to young doctors. And if young doctors are happy, we can definitely proceed to working group last call.
Okay,
Thanks.
thank you.
One more. So it's correct to assume that this work nicely together with the known implementations. For example, Bruno's open source implementation and perhaps ZTE's implementation.
And it's produced by Bruno's implementations, the experience, and some of our product implementation experience. Yeah.
Yeah, and I already reviewed an early version. I gave a lot of comments. It looked okay, but like I say, I did not review the very latest version. I will put it on my endless to-do list. Yeah, to do it pretty soon.
Okay. If Tony can review it again, it's great. Thank you.
Yeah, I will do it because it's important for me as well. So, at the end, we don't end up with a Yang model, which is wonderful, but, implementations don't comply to it or don't properly support it. If Bruno reviewed it, ZT reviewed it, I reviewed it, I think we'll have something pretty good on the table here.
So that would be really great to have implementation report on this. If we have working implementation, that's great addition to working document. Yeah,
agreed. Yeah, some kind of implementation experience would be good. I wasn't aware that Bruno was implementing anything on the Yang stuff. I know that he looked the model over, but wasn't aware there was any implementation work going on.
Okay, thank you.
Okay, thanks everyone. And next presentation is Rift key value registry by Jordan.
All right, thanks everyone. So my name is Jordan Head. I'm just here to present the Rift key value registry. The actual KV details are defined in the main spec, but this further details a lot of the details pertaining to like structure and key types and how those are maintained. Next slide, please. So just a bit of a primer for those unaware who haven't looked at it in a while. Basically, KV ties are used to disseminate information to other Rift nodes. Pulling this little quote straight from the draft, right? The data contained within these KV ties can be used for any imaginable purpose. So we give you just enough rope. KV ties are flooded north or south, and they're tie broken based on highest level and then highest system ID. That's required by south flooding, but north flooding, while it should adhere to that, doesn't have to. As far as use cases, we can jump into the next slide, please. So I'll leave it for the respective presenters today to kind of elaborate on their specifics. But as far as current use cases, so auto EVPNs, one thing we're looking at is basically leveraging KVs for necessary operational information. The relationship between the overlay and the underlay for state. SRIFT is actually using it for disseminating the like sRGB system ID sort of details to facilitate forwarding for SR. And then finally, while there's no mention of it currently in the multicast RIF implementation, it's that I think there are some considerations for doing so, but that's something up for a little bit more discussion. And lastly, it's not listed on here, but the draft itself does make some considerations for like IP MAC binding and security rollover considerations for like the risk security model. If we can jump to the next slide, kind of get into the format, what it looks like. So basically, this is a high-level overview. the first, we have 1 byte that signifies whether the key itself is well known, which kind of as the nomenclature signifies that it would be something that implementations, should support. It can also signify OUI, which is basically just vendor specific or company specific, and they use their previously assigned OUI space. And finally, there's an experimental identifier as well for any other use cases. The 3 bytes for key identifier itself describe the the structure and the specific elements within the values field. So it's, and then kind of finally it's the data itself. And if you jump to the next slide, there's a 30,000 foot view example of what we can do. So if we were just for the sake of example looking at a well-known TIE and or KV, it can contain any data or data structure. It's not limited to strings or integers. We could even put another thrift encoded data model in there if we wanted to. But again, it's your miles may vary. You can do whatever you need to with it. I guess next steps would be co-authorship and comments are welcome. Feel free, and then we can pursue last call after some feedback. And last slide, if there are any questions, I can try and address them now, or we can follow up offline.
I have a question on the last slide.
Sure.
So that example 1 there, is that a key ID?
Yeah, that would be the key identifier itself, yes.
Does the key identifier itself includes both a type or an ID, or because for example, if we want to encode some segment routing information, I assume we would have a specific type for that, and then the key ID. I assume the well-known is not exactly a key type. It's mainly is a property of a type or whatever.
I think really speaking, what we get there is a registry, and you just get the 1 and the 2 and the 3 and the 4, and that's it. And if that within the key needs further differentiation, that's already part of your data. So you say it's something, but for this node, well, the node becomes part of the data. I do not think we should start to structure the key any further, but it's a good discussion.
Okay. So you're saying that key ID is part of the value?
No, it's not. No, it's not. It defines what you talk about, but then the thing itself is in the data, right? And look, if you, for example, go, I'm unhappy with that, then you have 1 byte in front. So beside the well-known, we can have something like segment routing purposes, and you just take a value, and then you run and you do behind whatever you want. But you still have to keep to the structure key and value, because we need tie breaking, right? If the same key ID comes from multiple places.
Okay. Well, I guess when it comes to the SR specific one, we can have more context to ask.
Right, you either just grab a lot of well-known, it's a huge space, or otherwise you just say, oh, I want something that is just SR, and you take the first byte, you take the value out of the registry. Both are independent registers.
Okay. Okay, thanks. I'll defer to later. Yeah.
Any more questions? Okay, let's move on.
Thanks.
Next presentation is, thank you, Jordan. Thank you. Is segment routing with Rift. Jeffrey is to present.
Okay. All right, so this is segment routing with Rift. We have co-authored myself, Jeff, Jordan Head, who joined recently, and Don Fedek from some time ago. Next slide, please. The segment routing draft was actually published some time ago. We never really talked about it much. It was not presented before. So this is the first time we probably present it here. So let me first start with a comparison with OSPF or BGP-based segment routing. Typically, each router is provisioned with the sRGB information and the SID information, and then those information is flooded throughout the SR domain. Notice that the provisioning is done on each router based on centralized planning. Even in the old days, before SR or SDN came to life, all the provisioning is done centrally, maybe in the head of an operator, and the planned result is then carried to maybe on pen and paper, and then entered into the individual routers, and from there the provisioning information is flooded out. Nowadays, of course, you can use netconf VM or other means to send the centrally planned information to the routers, and the routers then flood the advertised information. Next slide, please. Now, about traffic forwarding, there are two ways of doing SR forwarding. The first simple one is you forward traffic based on the IGP or BGP routing. Just use a prefix SID. That is basically replacing LDP with IGP or BGP-based label distribution. Nothing special there. The next one is you do actual traffic steering based on the SID list in the packets, and then when each node will route the packet to the segments represented by the top SID. Once the packet gets to that segment, then the top SID is popped, and then continue to route to the next segment in the list. That when the ingress router needs to put the SID list into the packet, it can be back to determine what to be put into the packet. It can be either done by local calculation or based on the SR policy programmed from the SR controllers. Next slide, please. Now, compared to RIFT, how this is done, the sRGB and SID distribution, how it is done, we now do not provision those sRGB or SID information on the non-top nodes. There will be no flooding from those either. Instead, the result of central planning is flooded south using the Kiwi mechanism by the top nodes. Of course, the top nodes need to learn all those provision information from the orchestrator. So this actually combines a two-step process in the IGP or BGP case into a single step, and that perfectly matching the ZTP principle of the RIFT. Next slide, please. So about traffic forwarding, we only care about the traffic steering based on the SID list. In other words, a label stack. In particular, SRv6 is not in scope for now. And then when it comes to the how to determine the SID list, we will only rely on SR policies programmed by the controllers. And then when we do not have parallel links or multi-planar topologies, the leaves only have northbound default routes, so they cannot determine the SID list. That's why we rely on the SR policy from the controllers. And we only need to care about node SID because when you have no parallel links, the node SID is all you need. Besides that, we don't see benefits for prefixes that are not for nodes. Now, if you do have parallel links or you do have multi-planar topologies, then we need to have adjacency to choose the right link or right plan. For that, we can use SR or LB local base for the SR for the SIDS. We have some outstanding discussion on how that can be done. This will be addressed in the future revision. There is one issue we would like to call out here. RIFT protocol itself does not require loopback addresses in principle. Now notice that SR traffic steering is based on routing to node segments in the seed list. So we must have individual routes to those nodes in the seed list. Now, for those individual routes, it would be easier to have the routes based on loopback addresses, whether it's IPv4 or IPv6, instead of based on the system IDs. You could do system ID, it's just that now you have a different table for those routes based on system IDs. And also consider that operator may want to do management using those using loopback addresses anyway. So if you put all those considerations together, one question is, should we simply require loopback addresses? That's one question we want to bring to the group for discussion. As mentioned in last slide, adjacency will also be addressed in the upcoming version. Next slide. So we use KB to distribute SR information here. So we have two boxes here. The first one is that we need a key type to describe that this is for SR purpose, and then we have the next box is for the specific SR information. Here we need to identify the system ID / loopback address, basically specify which node this is for, and there we have the label base, label range, and node state, and potentially other information in the future, especially for how we advertise the adjacency state information here. So going back to my earlier question about KB registry, here you can see that there is a system ID / loopback address to identify which node this is for. So that is sort of like a key identifier to me. And what's the relationship with of that information and the sref node here, and what is TBD2 versus TBD? So that's the ties back to the question I had earlier. Next slide, please. So obviously we seek comments, and we will address the outstanding issues, and after we settle those outstanding issues and revise the drafts, at that time we will seek working group adoption.
Any questions to Jeffrey?
Yeah, so I stand accused of not having, Tony, Juniper. I stand accused of not having read the newest version, but my observation is that you start to define those things. And what you suggest will work fine in principle. Make sure that you keep very precise account what is northbound and what is southbound in terms of key values that you want to redistribute. Because first, mechanisms are different, right? Time breaking. And second, it has all implications on scalability of the solution.
I got your comment about make it clear it's north or southbound. What's the second one?
Nothing. What you suggest in principle as the key value, the way you want to distribute it will work just fine, yes. And the system ID and the loopback, well, that's kind of implementation specific. Loopbacks are relatively trivial to get around in Rift. So why not? But then you impose addressing on the whole scheme. So beware what you wish for, because if you work with system ID and a full ZTP, if you start to talk about loopbacks, then you better describe how to automatically derive loopbacks from system IDs, which theoretically can be done, or you are bound all of a sudden to force people to address loopbacks on the fabric rather than have it ZTP.
Yeah. One really question is that in a Rift network, when you do not use loopback address, how do you normally manage the nodes? Or
Well, how do you SSH into an Ethernet switch? You don't. So if the stuff works well enough, why bother? And if you need to, well, then you need loopbacks, yes.
Yeah, I think there's a larger picture. If you are planning on traffic engineering and to do explicit stuff, probably you would want to be able to address the node specifically. So it's not a cattle anymore for pets. But practically, Tony, to your comment about scalability, if you look at non-Rift network, the process of provisioning is orthogonal to process of discovery. So you would go to your orchestration system and provision RGBs, seeds, IP address, and everything else, and then you would use a dynamic part of network to actually do auto discovery. BGP allows to talk to the controller and report as RGBs and seeds used. Here you already know what they are, so there's no process of auto discovery. Everything had been discovered before. I mean, you don't need to discover. So it addresses kind of much higher scale that could be achieved here.
Tommy's raising his hand. So, but yeah, bigger discussion maybe list, but arguably you could build a full SR thing fully ZTP. If you have system ID, you could derive all these blocks and everything and just distribute them, and you don't need to configure everything. But I think that is too long for the mic now.
Okay.
So,
Thank you.
Yeah, and in non-planar topologies and with single links, absolutely, there's nothing. You just need to reach next node. In more complex topologies, probably something more would be needed, but this is something that should definitely be addressed in the draft for implementers.
Okay. I'm done. Yep.
Thank Jeffrey. Tony, now it's you again.
You have people raising hands.
Are there more questions?
I wanted to make some observations more than anything. I can leave this to the mailing list for if we have time. Go ahead. Basically, I suppose in terms of having loopback addresses,
I couldn't hear.
Your audio is breaking.
it's breaking up. That's not very useful. I'll save it for the mailing list.
Thank you. Tony?
Okay, so now for something completely different, which is properly unsurprising when I'm showing stuff. So this is actually someone else's idea, which I helped to flesh out, and there's a bunch of other people who contributed a lot because it's pulling a couple of technologies together. So it's lots of Jordan's work, Wen's, of course. I kind of fleshed out the Rift part based on somebody else's idea. And we call it Auto EVPN, and I show in the next slide the motivation and what the hell are we up to. Next one, please. Right, so first I say, I mean, what are we doing? Right? What are the drivers and what is the vision, what we're trying to achieve? Then I show you the architecture of the whole thing and flash a bunch of first details to give you a taste what's coming, and then, next steps, the work. Next one, please. Right, so put on your reading glasses. So what's the drivers and vision, right? So if you watch Auto EVPN, right, then it's a technology that claims to replace L2 as a technology. Now, Ethernet L2 is famous for the fact that its configuration consists of literally no configuration at all, right? So you just plug in Ethernet switches and guess what? They work, right? STP, no one even knows what STP is. Why should they? So when you now start to deploy EVPN as L2, you start to deal with the fact that it needs quite significant amount of configuration. So you either take a magic controller. I mean, nothing wrong with that. It has its own beauty, and in larger deployments, that may be absolutely a better solution, right? Because EVPN scales way bigger than L2 could, right? And it was one of the undoings of L2. And then you face your own set of problems, right? So how does the controller find the boxes, and how does it know which box is actually what in the whole EVPN topology, and so on and so on. Or alternately, right, you go and manually, and lots of people do that, you go and configure your L3 IP underlay first. You build the fabric. And we're talking always EVPN on the fabrics, which is, where it's being, I would say, prominently used, if not actually used in most of the cases. So you configure L3 IP underlay, which means you go and address a lot of stuff, all the links, and with the v6 link local and forwarding over v6 and v4, you have a little bit less work because v6 does pretty good work of the whole thing. And then you go and provision your underlay protocol, unless you run Rift, right? So you have to give IDs and you have to configure the peers, and IGPs are a little bit better about that. And BGP has some special hacks where it tries to lessen the load, and you start to configure BFD and try to bring your underlay up, and then you go and debug it. And then you start to configure the L3 IP overlay to get your EVPN. So you bring up your RRs where you need them, which need cluster IDs and loopbacks, and then you start to bring up the leaves, right, which actually have the C interfaces only. Then you need again cluster IDs and loopbacks for VXLAN. We're talking EVPN VXLAN because this is the most prevalent case today by far. And then you need some loopbacks for IRBs and route distinguishers for type 2, type 5s, and route targets, VLANs, VNIs, and I probably forgot a bunch of more things. And then you go and debug the whole thing. So can we have the L2 simplicity back for EVPN? And that's the driver, that's the question we ask. And we think that with Rift we can. The next one. So what is the architecture of such a beast? Next one, please. Okay. So it hinges on a couple of key observations, which are unique to Rift so far. And first, your IP underlay is solved, right? Unless you really want to SSH into the nodes, and you possibly want SR and other frills and things. But if you just want basic IP in any flavor, V4, V6, V4 over V6, both, stuff just magically comes up, zero config. Well, you have to fix the top of the fabric, right? Because the protocol doesn't have GPS, so it doesn't know what is up and what is down. And that arguably has nothing to do with geographic location either, right? So only humans understand what is the top of the fabric. So you fix this, whatever you have, this couple of top of fabric, and you're pretty much done. You have the IP underlay. And then you start to observe that Rift actually has enough topology understanding, because that stands direction to figure out where to put the RRs into the fabric for EVPN and what are the leaves that will be running the CE. And then you start to realize that every node actually has enough information to run all the elections and computation of necessary values to configure, to provision everything for EVPN in a fully distributed fashion. So you don't need a controller. You don't need additional synchronization. You have enough information everywhere to derive what you need to configure a full EVPN overlay. So when we started to work on the stuff, a couple of things came up where we extended the architecture, such a simple first set of observations and solution with a couple of things that came up. So one observation is that works fine on fabrics with different, number of pods, different heights of pods, different fan outs in every pod. That is not a problem at all. Then we started to observe that if you watch EVPN, how it's deployed in 80% or 80% plus of the cases that we see, is that people have two types of VLANs. They have VLANs that they want to stay purely on the same fabric, and they want VLANs that may be stretched between fabrics. And all of a sudden, you start to realize that a fabric ID is a concept. So if you want this thing to work over multiple fabrics, arguably, then you really want something like a fabric ID, which is still ZTP, because if you don't provide it, it's you just take a default value. You take one and that's it, and you run with it. But if somebody wants something more sophisticated, run multiple fabrics and stretch VLANs, then they will need the fabric ID, which they basically, every switch needs a fabric ID. And then we can derive literally VLANs that stretch and do not stretch. And this little picture shows you the reference architecture, the RR side at the very top. After long discussions, that's where we ended up with. And there's a bunch of them, of course. And then on the leaves, we running integrating IRB, also type 5. So when you read the draft today, it is sketchy because we didn't have much time to publish it. So we omit right now all the computation of the values. There's no type 5 and so on. The architecture is fixed. There's all the placeholders, but we didn't fill the stuff in. So next one. So I show you a bunch of details to show that this is not just PowerPoint, that's actually pretty real. So if you a little bit know ahead of the curve, you will know what programming language that is. But basically we'll provide all the derivation as algorithms, because it's so complex that, you know, verbal description is iffy. We have some very simple verbal description in terms of what kind of things influence the derivation of the value, but then we provide precise algorithms. So here's an example of all the stuff that you have to pull out on all the leaves and all the route reflectors to configure. So you need a cluster ID. You need a V6 loopback, you need a type 5 V6 loopback, which is different, a type 5 V4 loopback, and a BGP router ID, and the autonomous system. And I'm showing you how this thing can be computed, right? So in the decoding further, you see how, for example, a cluster ID is derived. Derived the same way as the private AS, and it's basically the fabric ID, which we shift a little bit and add it to the smallest private AS, and then we mod it with, you know, so it doesn't run out of the private AS space. And that's good enough. So you have a private AS, which is fabric dependent, and you have a private AS, which is, you know, which can serve as a cluster ID. And I show you, for example, the router ID that you derive. And this is not only dependent on the fabric ID, right? Because on the same fabric, everybody needs the same cluster ID, because we basically route reflect over the same cluster, multiple route reflectors. But the router ID is derived not only from the fabric ID, but also from the system ID, right? So what you do is you shift things a little bit around and you XOR a bunch of things. And what I'm not showing, we will be seeding with, you know, probably a small array of pretty good random numbers. So the whole thing has, you know, lots of entropy going for it. And the architecture hinges on the fact that you will be running on a V6 fabric, because otherwise simply all the interface addressing, the V4 interface addressing becomes unresolvable, right? You somehow need a centralized instance that takes a 10*/8 and assigns everywhere unique addresses, and that's a major pain. Whereas V6 will derive link local for you, and they don't even have to be unique, but they will be working fine. And the V6 loopbacks we derive are good enough to provision DNIs and run BGP sessions and so on. So all this stuff will be flashed in. Next one, please. All right, so what do we have to add to Rift? Nothing, but we choose to do a couple of optional things. So there is a suggestion to add optional version on the lines and the ties, node ties only. With the only purpose to prevent us from forming adjacencies between, you know, EVPN version 1 and auto EVPN version 2 for the future. I think that is a nice thing, right? Because we don't want to mix that. We also want to figure out if we have nodes within the fabric that do not support auto EVPN and maybe should, right? So we'll form adjacencies to them, but maybe at the top of the fabric, you could see that certain leaves do not run auto EVPN. And they will give you some, you know, useful information. And in case we want to really go multi-plane support and we want a better route reflector architecture in the sense that we don't want too many route reflectors and we want to spread them across planes. When we thought through the issues, we'll need a new tie that only goes northbound on the tops, which describes the plane, basically all the system ID of all the of the whole plane. That has to do with the election algorithm. If you look at the election algorithm in detail, you understand that otherwise you'll not be able to spread across planes. And then, you know, there is a difficult problem that if a single plane goes down, you could take down all your route reflectors and then flip over. So the election algorithm is also built very carefully. So a single guy joining cannot start, you know, flip sessions around. What also comes now is that there is a strong desire, of course, once you run something like that, to have some information, whether it came up, whether all the BGP sessions are up, you know, and how many prefixes did EVPN put on a leaf and so on. So the type 2 MAC addresses, for example. And that we can do by basically sticking a bunch of things into the key value store and just flooding it up. So that seems like a small investment. It's strictly not protocol, right? But it's pretty handy because you don't ask people to deploy anything except Rift, and they get some minimal insight into their EVPN being, you know, auto-configuring and coming up and working, and whether anything is wrong and what is roughly the scale on each leaf and so on. I think that's it. Next one. I think it's the last one of the lot. Oh no, yeah, so we will fill in the algorithm, we will add the type 5 IRB variables and algorithms as well, which right now are commented out. So the key value thing, I don't know what it should be part of this specification. I think it should, but maybe we pull out actually a different draft for that. We welcome co-authorship, whoever is interested in working on that. As from to the implementation, if you want to run the whole thing, well, you need the whole Rift. But if you're just interested in implementing the leaf side of things, a Rift leaf implementation is enough. And as the basic spec describes, it is actually much simpler to implement the whole protocol, right? You basically need a very minimum flooding northbound, and you're pretty much in the game. And you can you can also omit flood reduction, you can omit bandwidth balance, you can omit, you know, 80% of the spec if you just want the very basic leaf implementation, but you'll get enough information actually to fully participate in auto EVPN. That was the last, no? Is the next one? No, I think that's it.
That's the last item, yeah.
So I think room for comments and questions now.
Questions, comments?
I cannot hear what you're saying. Where that is, Jeffrey or Jane?
Questions, comments?
Hello, can you hear me?
I can
Yes.
hear you.
Oh, I haven't read this draft, but I'd like to know where this function be used, if it will be used between PE and CE, or it can replace the BGP control plane at all?
No, this is strictly aimed at EVPN, right? And what we're seeing is people are deploying IP fabrics, and very often they are deploying EVPN on top of that to get L2. And they are deploying to the leaf or slowly towards the servers because of the multi-homing issues. So the fabric starts to look like one big Ethernet switch to them, in a sense, with VLANs. And that's what we're addressing. That's something that is being deployed a lot, and, you know, preconditions have significantly complex configuration. And there are controller solutions, but that's something where you could buy just 3-4 switches and literally stick them together like Ethernet switches and you get EVPN with the same simplicity as deploying L2. I mean, it will scale to a much bigger scale, but at a certain point in time, I think the manageability of such a thing will become iffy, right? But I don't know, maybe people will, I mean, Rift will support it at any scale, and so will EVPN. So, you know, sky's the limit, really. But it addresses, you know, a specific deployment use case, which, however, which we see a lot of, really a lot.
Okay. I will ask it in the mailing list. Okay.
Actually.
Thank
Sorry, Sandy, what did you say?
I
You'll
think
send them
I
out.
just, yes, I think I just get later for your answering. So I think I will send the question in the mailing list. Okay. Thank you.
Answer that. And if you know, if you want, you know, co-author this interest from your side or your company, you know, to work and improve the solution, more than happy.
Agreed. Thank you.
Alvar. If you are talking, you are muted, I would say.
Ah, yeah, there we go.
Yeah.
Double mute. I said Alvaro Return Routing 80. So just a quick comment. As this progresses, it would be good to keep BES informed. I'm sure that if this is a very common scenario, they would be interested. There might be people there who want to maybe collaborate or have some other comments. So just that. Thanks.
Already addressed.
Up in BES, actually. I got the tail end slot in BES this time. So they'll be aware of what's going on. Absolutely. Yeah. And the discussion where it should be adopted, should it be adopted, and so on, is all upcoming. I just wanted to evoke some interest and see who is, you know, willing to jump and help.
Okay. Personally, I'm very happy to see EVP and draft coming into Rift. I mean, it leverages unique capabilities of Rift, and that's great stuff. I mean, auto discovery capabilities absolutely unique, and that's really great next step development for Rift. We are on time. We are actually 2 minutes over. Thanks everyone for being here with us. Protocol is progressing really well. Tony keeps us busy and happy. So we will see you virtually in San Francisco soon. Thanks everyone and have a great day.
Thank you.
Next time. Bye-bye.
Bye.